So here we are just starting this session and we are developing or learning the threads, how to create a threads, different ways to create a threads like that. Right. So, generate, finish. So I hope you already know that how to create a project and how to. So we are using a JDK8. Simple, I have created one what we can call as package. So you can click on those and then you can new and you can create a package. Inside the package, you can create a class. So this is the class. So there is a two ways. So you can say extends thing. So we have already discussed, right? Java doesn't support a multiple inheritance. So if you are extending a thread, you won't be able to extend any other class. So if you are planning to extend any other class, you should not extend the threads. Point number one, right? So that is one thing. Now, what will happen here? In that scenario, right? This particular class already adopting a behavior using the inheritance of it. The thread is a right is a thread of execution in a program. So Java virtual machine allows an application to have a multiple threads of executions. Okay. Every thread has its own priority. So thread with a high priority are executed in preference to a threads with the lower priority. So basically thread scheduler is helping to us. So thread scheduler. So you cannot force to a thread scheduler which thread will executing first, but you can request it. So each thread may or may not also be marked as a daemon, right? So when code is running in some thread creates a new thread object, a new thread has its own priority initially, set equals to the priority of the creating thread. Okay. And is a daemon thread if the only if the creating thread is a daemon, right? If you are basically setting a same one thread there. So when a Java virtual machine is startup, there is a usually a single non-daemon thread, right? It's typically called as the method name main of some designated class, right? The Java virtual machine continues to execute a thread until either of the following occurs. So it will continuously execute that what we can call as the operation if something is happening like that. If you are using exit method, system.exit, right? Or maybe runtime.exit, I guess, has been called, it will stop. All threads that are not daemon threads have died. It means all non-daemon threads will be died, then it will stop that, right? Either by returning from the call to the run method or by throwing the execution with propagate beyond the run method. Okay. So there are two ways, right, to create a execution of a threads. One is through a subclass of a thread, which we are just saying public class extend threads, and you can say long, and you can just see like that. And you can start writing the code it here. Correct. Then you can say thread like this. This is nothing but the priority. Anything you can pass it. And you can say p dot start here. In other ways, you can implement the runnable and you can what we can say runnable and put the run method here. So there is another way to you can say run method and you can just say new thread and you can pass the runnable here and you can dot to say start. Okay. So first we will just see how we can create a thread, right? So here right? So this particularly thread you will have okay, inside. So P is dot. You see the gate ID, gate name, gate priority, all these methods belongs to a right join run, correct? So start from the like this. Yeah. So you see inside run is getting printed here, even though we are not calling run method. So these are the lifecycle method. So first here we are just using as a creating a thread. Here what we are doing is starting a thread. Here what we are doing, correct? Running. So whatever logic you are putting it here, correct? This is basically you will see in that scenario this code will be getting executed. So if you wanted to perform some task using the threads, so that this particular thread, whatever code you are putting into a run method, that will be. If you wanted to have after performing this task, you wanted to say it has to be go for a sleep. You can say thread dot sleep. So it will be put it into a milliseconds, right? So you can say 100 milliseconds. It is basically throwing, you can say around try catch. So means you wanted to have some hold for 1000 milliseconds. Cause the currently executing thread to sleep. It will just go once this 1000 millisecond is done, it will again wake up and then perform some task like that. This is the way you can just do it, right? So many such time, let's say if you wanted to write a timer, something like that, you can do it. Okay. So you can perform some tasks and you can just do it and you can use that thread dot sleep. Now, another way is to let's say loan processing. Okay. So loan processing will implements this is a nothing but a marker interface. So it is saying add unimplemented method. So we have the run method. Where this run method here? This run method having a what we can call as here you can write some operation. Let's dot. Correct. Here you can say inside a run using a run. Correct. Now new class. Loan disbursement. So loan disbursement we have here, correct? Now this particular class we will use it. Loan disbursement. So what we will say, thread T is equal to new thread, correct? Here what you will say, PS is equal to new PS, right? Here you can pass this PS, correct? Now T. So T is nothing but the object of a thread here, correct? So it will start. Now what we are saying here, run Java application. You see inside the run using the runnable. So this loan processing class will behave like a threads. So if you wanted to create a multiple threads, so what will happen here? You can create a one more object, right? So this is a T1. This is a T2, correct? Here you can say T1 dot start. Here you can say T2 dot start, right? Now, so three threads we have created now. So each and every thread is performing a same task, right? But we have created a three different threads here. Now you can say run Java application. So you will see 3 times it is being printed here. So there are many such methods also there. Dot right? So you can say details. T dot get ID. It will give the ID of a thread. So you need to understand this thread management is done by the thread scheduler. Okay. And we have already discussed some of the basic points for that, how this method area and other things are getting used, right? How threads maintaining its own stack and everything. So that is also we have seen. Like this, all these methods, thread information, many such things you can access it, and there are so many different constructors are also there. Just like this is a one constructor, like this 4 or 5 different constructors are there. Okay, so here you can see different constructors are there. Okay, so you can use a different constructors, you can pass the name and all these things. So like this, you can print the information also. Correct? You see details, right? So is basically the gate ID is 10. Name is basically thread 0, right? Get priority is 5. So priority is from 1 to 10. Active count is 1. So you can understand that these terminologies and details also. Okay. like this. So let's go much more another facility here. Let's say something we call static counter. Mm, uh, So let's say how the counter variable will be. Correct. And here you can also see um, this counter variable you can access through an object. So what will be the counter variable output, right? The value of counters. So you see the value of a counter is here, it is gaining coming as a zero. Hmm?
Yes, yes, yes.
So why this value is coming as a zero? If next time again I'm just seeing run as now you see the value of counter is 2. Now you will see some different answers. Now this value of counter is 3. Again I will run. Now the value of counter is 0. So how you will make sure you will always get the correct value of this counter? Then this basically a thread safety, right, and multi-threaded environment. How you make sure this particular problem you need to fix it, right? So maybe you can use if you are using as a volatile variable, you can try. But for atomic operation, you can use an atomic input. Then you can try.
Okay.
So that is the
Easy.
way. And there are different other scenarios you need to understand when we are using a different type of objects, array list, some different objects, custom objects, right? Or maybe
Okay.
any other different collection classes. So many things. So multi-threaded will be a very complex if you are not properly handling it and if you are not writing a proper code. But Java JDK 1.5 onwards, they also solve some of the problems because they have given the executor framework and you can say the task-based concept. So we will learn into a next session, but at least till that time, you can understand how this particularly problem. So let's say if you will fix it. You see, now let's try again. Now value of counter is 1.
One.
Now value of counter is
1.
value of counter is
1. Okay, great.
value of counter is
3.
now here it is 3. So again, we need to just look into this code here, even though if you are using as a atomic integer. Okay. So that is we will debug and we will sort it out, correct? But till now, you need to understand these kind of problems are really very critical and creating so much problems here. And class level variables are always available for escape, and they are potential, you can say, available for creating so much problems when we are going for a multi-threaded environment. So you need to be careful when you are using a class level variables and it is available. It's here you are not using any other it is basically a default, right? So there is a no restriction also. So you need to understand these things also. So we will see about the thread safety much more in details.
Yes, yes.